Hi team, these are the practice problems for 1 through 3, so we'll start with number 1. For this one, parent functions, you guys did really well. If you're watching this, it's probably just because you messed up like the names of them. So we'll just quickly go through these. If it looks like this is parabola, it's called quadratic graph. If you see the V, so this is like the U shape, but if you see the V shape, this is absolute value. Absolute value. The shooting star, as Ms. Name says, it's like a point and then it shoots out like that, like a shooting star. This is the square root graph. If you see something that's like this, it looks like a cubic, but it's on its side. It's also kind of looks like the square root, but it's the other direction as well. This is the cube root. So the one that looks like this, the little index of 3. And then we can see this one is getting really, really high, super duper relevant. This is the exponential graph. It's your coronavirus graph, if you will. Your number of cases going up very, very quickly. And then finally, if we see these lines here, this would be absolute value because we see literally absolute value in the problem. For our parent functions, if we're drawing them from the graph, we need to like identify what the parent function is. So in this case, if I took away the 4, I took away the -1, I would be left with x squared. So I need to draw a quadratic, a parabola. If I took away the +6 and the -3, I'd end up with the square root of x. So I need to draw the square root graph. And then with this one here, take away the negative, the plus, and plus, I'd have x to the 3rd. So I need to draw the cubic graph, which we haven't talked about, but looks like this. Right, so this is your cubic. You can see that it is like the up and down version of the cube root graph. So that is section 1. Pretty simple for section 1. For number 2, we're doing transformations. So transformations, we have to give the name of the parent function and describe the transformation. So for this one, we'd say, okay, x squared. I know x squared is a quadratic or a parabola, right? And then I see a -1 at the end. So one way you can think about this, you have whatever's happening to x, usually if it's in parentheses or if it's in absolute value bars or if it's in the square root, and there's a number here that might be plus or minus a number. Whatever this number is, it's the opposite action. The opposite action is happening left and right. So if it's like -3, it's going to move in the positive direction 3. If it's +3, it's going to move in the negative direction 3. And then we have plus another number, could be out here. Whatever this is up and down. And this acts normal. Right, so if it says +3, it's going up 3. If it says -3, it's going down 3. Right. A number in front here, if it is like a whole number, or well, if it's a number greater than 1, if it's greater than 1, it's getting skinnier. It's like getting taller faster. And if it's a fraction, so if it's between 0 and 1, if it's a fraction, it's getting wider. And then finally, if there's a negative in front, this would flip it over the x-axis, right? So if it's like this, it'd be flipped over like this. So if I see a -1 out here, this is like this portion of the graph, and that's moving normal up and down. So in this case, we would say the transformation is move down 1. Move down 1. That's different than say like this -2. This -2 is inside of the square root with the x. So that's like being inside here. That would be like this one. So it's going to be the opposite. It's moving left and right. So in this case, I'd say, okay, started with the square root graph. And my transformations, so it says -2. So so the negative direction is the left, but I want to move to the right because it's the opposite. So this would be right 2. So we move it to the right 2. Okay. Let's look at this one here. So for this graph, I see that there's absolute value. So that's what I'm starting with. That's my original graph. I see a negative in front. So that is going to flip upside down. So it would be the V like this, but we're going to flip it upside down like this. So flip upside down. That would be the negative. The 4 is going to make it taller, right? 4 makes it taller like this, or skinnier. So skinnier, factor of 4. And then the +5 at the end is going to make it go up. So shift up 5. So in this case, there were 3 separate things that are happening, 3 transformations. Okay. You should be good to go on the rest of them. All of the answers that you'll need are here, as well as the names of them are here and the transformations are here. So you can sort of mix and match if you get a little mix up. So that is number 2. And then for number 3, we have function notation. I'll go through the first set with you. So it's telling you that this right here is this graph right here. So we are going to calculate f of 4 algebraically. So if it says f of a number like that, then they're telling us to replace x. All right, so if it says f of a number, we're replacing x with that number. If it says f of x equals a number, then we are saying, okay, the equation is equal to this other number here. So for this case, I would say, okay, f of 4. So x is turning into 4. So I'm going to go ahead and write 2. And I'm leaving that space open where the x is. I'm going to put in a 4. So it's saying the absolute value of 4, which would be +4, times 2 would be 8, minus 2 would be 6. So I have, I know that f of 4 equals 6. So this is the algebraic piece. And then I'm going to go ahead and look for the, I can look and see it on the graph to confirm my answer. So if this is x is 4, then 6 would be my, y value. I'm realizing that you can't see what I'm seeing on my screen. So hold on. Let me fix this for you. There we go. Okay, so we did this math. We plugged in the 4. The absolute value of 4 became 4. 2 times 4 is 8, minus 2, 6. So this is the coordinate. If this is x, if 4 is x, then 6 is y. So I should have a point at 4, 6, which I do. It's right here. That is my point on the graph. Okay. The same thing would happen for this one. So you're plugging in -2. So you'd have 2, -2, minus 2. The absolute value turns into positive, and then you can go from there, right? If we are thinking about f of x equals 3, that means that this function here is equal to 3. So we're saying f absolute value of x minus 2 is equal to 3. So I'm going to solve for x. I'm going to add 2 on both sides. So I have 2 equals 5. And go ahead and divide by 2 on both sides. So I get the absolute value of x equals 5 over 2. And remember, what's inside could be positive or it could be negative. It's always going to equal that positive 5/2. So I'd have x equals positive 5/2 or negative 5/2, which is like 2.5, right? 5 divided by 2, 2.5. So we're saying x is 2.5 or negative 2.5, and y is 3. So if I'm looking at this graph, I'm going to say, okay, x is 2.5, so I have 2. This would be 3, so 2.5 is like right here. And then my y value should be 3. Up here, I see there's like a point right here, and that would be right about 3. And the same is true over here, negative 2.5. Here's negative 3, negative 2.5. This would be 3 right here. Right? So I can confirm graphically that this is correct. Okay. So most of our mistakes here were just basically like, were we supposed to plug in x, or were we supposed to set it equal to x? Right? So f of a number, plug in 3 for x, f of x equals 3, set equation equal to 3. That is your big hint for number 3. You got it, guys. You can do it.